class. I hope you are all doing good, well and ready to listen the class. You can remember about the last class. You have completed unit 2 and now we are entering into unit 3. The unit 3, I will show some things. Can you say how we name that in chemistry? What is this? Chalk piece, right? How you name this in chemical terms? In chemistry, what all that we see is grouped under a single word in chemistry. That we are going to learn. What is this? What is this? This is your chemistry text. It is book, but have other name also. Then, what is this? Sellotape, but it can be grouped under some other things. And what is this? Notebook. It is also can be grouped into one. All this can be named as matter. What are all this? This is a matter, and this chalk piece is a matter, this sellotape is a matter, and this book is a matter. So generally, anything in this world has some mass and occupies some space. When you weigh this chalk piece, it may be 100 gram, 50 gram, 20 gram, like that. It is occupying some space in the nature. When a thing is occupying some space and it has some mass, it is called matter. When a thing is having some mass and occupying some space, it is called matter. Depending upon the properties like shape, size, weight and its flowing nature, all this we can divide this matter as states of matter. What are the states of matter? Do you know what are the states of matter? There are 3 states of matter. One is solid state, and the second one is liquid state, and the third one is gaseous state. What are the 3 states of matter? Solid state, liquid state and gaseous state. Now, what is this solid state? What is the solid state? Any solids that will be having a definite shape, definite size, and it will be very difficult when you want to change the size or shape of the solid. It takes, we have to apply some heat or we have to apply some pressure. Easily you cannot change the nature of the solid. So it has definite shape, definite volume, and it cannot be changed easily. And some examples of solids are, when you take this butter, it will be very light in weight. So that is the example for lightweight solid. Then when you consider diamond, it is more weight, right? More hard. So it is the hard solid. Other examples can be book, this chalk piece is a solid, and chairs, stone, all these are examples of solid. Sugar, salt, all these are the examples of solid. Then the next one is liquid. This has definite volume, it has some mass. If you weigh this liquid, it has some mass. But when you consider about the shape, it takes the shape of container. When you take a liquid, you take the liquid in cup, it takes the shape of the cup. When you take the liquid in big part, it takes the shape of the particular part. So, liquid is having a definite volume, but it cannot have a definite shape. It changes depending upon the container in which it is kept. And examples are water, milk, oil, then soft drinks. All these are examples of liquid. Many examples you can also say. For example, oil we have, water, juices, all these are examples of liquid. And this liquid can flow from, it can flow from one place to another place. When you pour this liquid down, it will not stay in the particular place. It will spread. It will move from one place to another place. These are all the properties of liquid. Then come to gas. When you consider this gas, this also has no definite shape. When you see the gas, it will be spread all over. When you have a balloon, this balloon fully it is spreaded. And when you consider some other thing, this room also filled with air. So, when you consider this gas, it is spreaded all over the area in which it is. And it can exert pressure on this. You can apply pressure on this gases. When you take a balloon, when you apply pressure, what happens? The shape of the balloon changes, right? So, pressure can be exerted. This liquid flows in from one place to another, but when you consider this gas, it spreads throughout the entire region. For example, oxygen, nitrogen, hydrogen, helium. These are all examples of some of the gases. You are clear about this? Go through your book. Just read, it will be in simple words, you can easily understand. The three states of matter are solid, liquid and gaseous state. Then the next heading we can see this one. If you read your book, you can clearly understand. We can go for the next one. Next one is factors responsible for the states of matter. There is a theory called theory of particulate nature of matter. What does this theory say? It says that all the particles are made up of very tiny atoms or molecules. All the matter around us is made up of a tiny particle called atom or molecule. When you consider this example, see, this is a cup. It has some tea or coffee. It is very hot. So, it is the gas, the vapors are coming out. These vapors are gaseous state. So, you can represent the gaseous state here. Consider this cup. This cup is solid. It is hot, right? It is solid. And think about this coffee or tea inside this. It is liquid. Now, depending upon this arrangement of atoms, we can have 4 factors. They are interparticle force, interparticle space, Brownian motion, and the next one is diffusion. These 3 states, the arrangement of atoms in these 3 states depends upon these 4 factors. Now see, solids. Solids will be very hard in nature. So the atoms are molecules. For everything the basic is atom or molecule. So in solids the atom or molecule are arranged very tightly. See this? It is arranged very tightly in solids. This is nothing but this cup indicates solid. Now come to this liquid. In this the atoms are arranged not tightly as the solids, somewhat loosely. Like this. But when you consider this gases, it is arranged, it is very loosely packed. This is about the three states. Now, how these factors play a role in these three states we can see. These four factors we have. They are interparticle force, interparticle space, Brownian motion and diffusion. In today's class we can just learn about this interparticle force and interparticle space. About this Brownian motion and diffusion, in the next class we can continue. Listen, this is the force. So you have two atoms like this. It is apart, but some force is needed to bring this near this or bring this near this. So that particular force is called force of interparticle force. It can be to attract or repel. Here this is, it will repel, but here it will attract because they are closely packed. It is loosely packed. So when you consider the solids, the interparticle force is very high, so it is very tightly packed. Then when you consider this liquid, comparing to the solid it is more, but comparing to liquid it is comparing to the gases it is more, and when you compare the force with solid it is less than solid. And when you consider gas, the interparticular force is very less. Then interparticle space. See this? The space between two atoms in this gas have many space, but when you consider this liquid it is somewhat less than that. When you consider this solid, whether there is any gap between two atoms, they are very close, so there is no interparticle space. So what is interparticle space? The space between the two atoms in a matter is called interparticle space. When you consider the solid, interparticle space is very low. There is no space between two atoms. When you consider this liquid, it is higher than the solid and lower than this gaseous state. When you consider the gaseous state, the interparticle space is high. The distance between the two atoms is very high. So this is enough for today's class. Just recall what we have learned. What's a matter? Anything that has mass and occupies some space are called matter. Then the three states of matter: solid, liquid and gas, and their properties. Solid has definite shape and size. It has definite volume, and liquid has definite volume, but it takes the shape of the container. Then example for solid: book, chalk piece, chair, stone. Example for liquid: oil, water, juices, etc. Then gas, the gases has definite volume, but the shape is, it spreads equally to all the places. When you consider a balloon, the gas will be equally spread throughout this balloon. So the spreading or distribution is throughout the entire volume. And about this particulate nature of matter. Depending upon this matter, we have three states: solid, liquid and gas, the properties. And this three arrangement of atoms in this three states depends on four factors. They are interparticle force, interparticle space, Brownian motion and diffusion. When you consider this interparticle force, the force between two atoms to attract or to repel. Then the interparticle space is the space between two atoms. The interparticle force is high in solids, low in gases and higher than the gases and lower than solids in liquids. And same way space is also very less in solid. It is higher than solids and lower than gases in liquids, and the space is high in this gases. In the next class we can start with the, let's talk two properties, factors, that is Brownian motion. They says about the movement of atoms inside the particle or matter. Then diffusion. Diffusion means traveling or joining. It comes in that way. So we can see the remaining two factors in the next class. I hope you all are clear about today's class. Go through your book, read your book. There are many activities given in your book. They are very easy to solve. So you can try those activities also. You can meet in the next class. Thank you students. Have a nice day.